Hello, and thank you for joining us for a discussion in review of the concept of concurrency. We're going to talk about really concurrency in the sense that it relates to delays to a construction project. It's a very specific and particular review of the idea of concurrency. We all kind of know, I think, what it means for something to be concurrent. They're occurring or existing simultaneously or side by side. So when we talk about concurrent delay, we're typically talking about delays that happen at the same time. However, we're interested in a particular kind of delay, which we'll talk about, critical delays, and we're particularly interested in how those delays affect the critical path of work and ultimately the project completion date. Certainly we're interested in that because it's a critical delay to the project that oftentimes drives damages or added costs associated with delay. And it might also be associated with liquidated damages. So we're typically most interested in, when we review delays on a project, in critical delays to the project schedule. So really, as we talk about concurrency, we want to make sure we're kind of on the same page in terms of what a concurrent delay is, how they might affect the scheduled project completion date, and how we might distinguish between concurrent delays and concurrent causes. This last item we'll talk about in our next presentation. Let's first just talk about concurrent delays. Simply, concurrent delays are delays that happen at the same time, that occur at the same time. You can see a graphical depiction of concurrent delays on this slide. The first bar is path A, the blue bar. This is its planned duration. It's supposed to start on day 1 and finish on day 40. You can imagine these days in a calendar, so that might be May 1 of 2009 all the way to June 10 of 2009. There's another path of work for this project called path B, and it only has a 30-day duration, also planned to start on day 1 but to finish on day 30. In other words, start on May 1 and finish on May 30th. The other bars depicted, there's a second bar under path A and a second bar under path B. And this represents the actual performance of the path A work and the actual performance of the path B work. With regard to the path A work, you can see that it started on time on day 1, but it finished 5 days late on day 45. The reason for that late completion was a 5-day delay that occurred basically from day 6 through day 10. You can also see that path B was delayed. Its green performance starts on day 1 as planned, but it finishes late essentially on day 40. You can see that the reason for that late completion, day 40 versus day 30, was a 10-day delay that started again day 6 and proceeded through day 15. So what we have here are concurrent delays. The 5-day delay to path A and at least the first half of the 10-day delay to path B are delays that are happening at the same time. They're concurrent in that sense. Unfortunately, or perhaps fortunately, depending on your perspective, it's not enough to know that the delays happened at the same time. We need to ask and answer another question, and that question is, are either of these activities on the critical path? Are they affecting the project completion date? We've already talked a little bit about why we're interested in that, but essentially, critical delays are the only delays that can affect the project completion date. So, in order for a delay to delay the project completion date, it has to fall on the project critical path. Now, just by way of description and example, path A, let's say that that's a path of work associated with the construction of a bridge associated with a highway project. And let's say path B is a path of work associated with the construction of the approach roadways to that bridge. What you can see is that overall it's anticipated that it will take quite a bit less time to build the roadways approaching the bridge than the bridge itself. So if you were looking to see why the project when the project would finish, you would focus on the longer path of work, that's path A, the bridge construction work. And typically when we look at a critical path, what we're looking at is the longest path of work through the project. Perhaps another way to think of that is the tallest tent pole. It's the path of work that determines when the project will be completed. So on this project, path A is the critical path. It's the longest path. It's the tallest tent pole. And we can see that that path of work was delayed 5 days. And I think the right conclusion from that is that the critical delay to this project is the 5-day delay to path A. Yes, there is a 10-day delay to path B, but you can see path B started out the project with 10 days afloat. Why did it have 10 days afloat? Well, because path B only took 30 days to complete, and it didn't really have to be finished until day 40 when the bridge finished for the project to be complete. So path B, in effect, can be delayed 10 days without actually affecting the project completion date. So path B has float, and the delays to path B really are not critical. So though we have concurrent delays, the 5-day delay to A and the 10-day delay to B, what you can see is the delay that really matters in terms of its effect on the project completion date is the 5-day delay to A, not so much the 10-day delay to B. So let's take these ideas and concepts and move on. One of the conclusions we should reach is that essentially when one is evaluating concurrent delay and when one is primarily interested in the critical delays of the project, one has to evaluate whether or not the delay falls on the critical path. So that is a primary and really important determination that needs to be made in order to sort out concurrency issues. And that's really the conclusions that we draw from our first example, that you can have concurrent delays, but they're not always concurrently critical. And in order to find those concurrent critical delays or to identify critical delays, you really have to look at the project every day and look at how the critical path is unfolding and look at how that path is being delayed. Let's go to another example and really talk now in more detail about concurrent critical delays and what they might look like. So for this example, we're keeping it simple. Again, we have three activities really. 2 paths. We have a critical path of work that includes activity A. That's a predecessor to activity C, meaning that it has to be completed before activity C can be performed. And we have a critical activity B that also has to be completed before the critical activity C can be performed. If you wanted to attach real work to these representations, imagine that activity A is the procurement of steel and activity B is the construction of the foundations. You can't really erect steel without foundations, so in this particular schedule, because the foundation work takes about as long to complete as the fabrication of the steel, these 2 paths of work are concurrently critical to the activity C, which is steel erection. Now, let's look at what happens to these activities. What you can see is that both activities experience identical delays. Both activities, delays to both activities start on day 21 and continue to day 30. They're both 10 days long. They both start on the same date. They both finish on the same date. They're both occurring to critical work. Critical activity A, critical activity B experience identical delays, same start dates, same finish dates, and both hold up the start of activity C. This is an example of exactly concurrent critical delays. Now, maybe something that should be going through your head right now is, while you understand why we would consider these to be exactly concurrent critical delays, you can also see that this is a fairly rare circumstance. In other words, 2 paths of work, both critical, both predecessors to another critical activity, both delayed exactly the same amount. mean, for example, we were talking about steel fabrication and foundation work. So, for example, perhaps the delay to critical activity A was a problem in the fabrication shop that prevented the contractor from being able to complete the steel fabrication. Likewise, perhaps the problem in activity B was the discovery of a differing site condition that prevented the contractor from completing the construction of foundations. You can also get to see from those two examples I just gave why the parties might be interested in figuring out who's responsible for these critical delays. The first example, a problem in the fabrication shop, might very well be the contractor's fault and responsibility, whereas the discovery of a differing site condition might be the owner's fault and responsibility, at least responsibility. In those circumstances, there might be a legitimate question as to whether or not the contractor might be entitled to a time extension, whether or not the owner might be able to recover liquidated damages for the contractor's delay, and whether or not the contractor might be entitled to additional reimbursement for the delays experienced. All of these items, of course, play out in the contract and depend obviously upon the contract provisions and the specific facts of each issue. And we're really not going to get into that right now, but it's by way of explanation as to why it's important for us to be able to sort out responsibility for delays and sort out whether or not delays are exactly concurrent or in fact not. So let's go to the next slide. Wrapping up our example 2, what we found is that the owner and the contractor delays were concurrently critical from days 1 through day 30. Both activities caused 10 days of concurrent delay to the project. So when we ultimately sort out the party that's responsible for this time, who might have to pay liquidated damages, who might have to pay delay damages, we have to consider the fact that these delays happened exactly concurrently. And we know, based on our analysis of the critical path, that they were exactly concurrent critical delays. So now let's go to example 3. And example 3 deals with a slightly different fact pattern. We have our same critical activity A and critical activity B, but you can see that the delays associated with each of these paths are quite different. We have one critical delay that ends before another critical delay. Delays start for both critical activities on day 21 and are concurrent. Concurrent delay continues for both activities for 5 days. In other words, the delay to activity A and B both start on the same date. They're both critical. One's an owner-caused delay, one's a contractor-caused delay. And for the first 5 days, they're exactly concurrent critical delays. Now let's move to the second part of the delay period. During this second part, we have one critical delay, in the sense that we have one path of work that's continuing to be delayed, not both. Delayed activity B starts really on day 26 through day 30 and is not concurrent with a delay associated with activity A. In fact, activity A is essentially complete as represented here, and now critical activity C is solely awaiting the completion of activity B in order to proceed. So if we go back to our example of steel in the top and foundations in activity B, the owner-caused delay is affecting the fabrication of steel only for the first 5 days, and the delays to foundation are affecting the contractor's delays to foundation are affecting the completion of the foundation work for an additional 5 days. Overall, the project's delayed 10 days. Let's go to the next slide. What should we draw as a conclusion from this particular example? Well, the contractor and the owner delays were concurrently critical for the first 5 days, from day 21 through day 25. If you updated the schedule each day, day 21 through day 25, what you'd discover is that both paths of work, both activity A and activity B, were critical in delaying the project completion date, and both were being delayed simultaneously. Then you see that after the fifth day of delay, that now activity A is completed. No further delay is being incurred by the project associated with the performance of activity A, but you see that activity B is not completed and it continues to be delayed. And as a result, activity C does not start. Activity C is critical. Activity B is critical. Activity B is solely critical. The delay to activity B is solely critical. And now all the delays to the project after the first 5 days are attributable to that particular cause. So let's review where we are now. Essentially, what we have discovered is that, yes, you can have delays that happen at the same time on a project. They can be concurrent delays. We call them concurrent delays. Yes, you can also have concurrently critical delays on the project, but you can see from the circumstances that they would be a fairly rare occurrence where two paths of work are exactly concurrently critical, and two delays, one on each path, happen exactly concurrently critical. Possible, but unusual. Then we shifted to perhaps a more reasonable example, or a more likely example, or a more common example. Probably the latter of the three is more likely, or more appropriate or accurate. And that is a situation where perhaps the critical delays start at the same time on A and B, but one of them extends longer than the other. And we can see that as long as they start at the same time and they unfold at the same rate, both paths can be concurrently delayed. Ultimately, however, the path A delay stops and the path B delay continues, and the remainder of the delay to the project would be attributable solely to the delays to path B. So, in both cases, we have concurrently critical delays. And the trick, of course, will now be to sort through the facts in the contract and determine, frankly, which party is responsible for and which the added cost that the project incurs as a result of the delay. Might the contractor have to pay liquidated damages? Might the owner have to pay delay damages? Is there a time extension due? That concludes this aspect of our discussion of concurrency. Our next session will delve deeper into that subject, and as you can see, might talk about concurrent delays where one delay starts later than the other. That will introduce us to the concept of primacy of delay. Thank you.